a question here that says express each of the following in simplest form. So let's start with the first one here. We have our set. The first one here we have x complement union x minus z here. Then we have a complement outside here. So now this here is set difference that we have inside the brackets here. So meaning that here we're simply going to have x complement union x intersection z complement here, and we have our complement outside there. So here, if we distribute this complement across what we have inside the brackets here, we're going to have x complement complement, which will just give us the set x here. Okay, so now that we've distributed the complement inside the brackets here, this symbol that we have here will change into intersection. So open brackets here, we have x intersection z complement like this. So now we're going to apply the complement that we have here into the two sets that we have. Remember from the demograms we said if you have a intersection b complement, this is simply equal to a complement union b complement here. So we use the same property here on simplifying what we have here. So we have x intersection here, we're going to have x complement, the symbol here will change, union, then z complement is just z here, like this. So now we apply the distributive properties here. So we're going to say x intersection x complement and x intersection or union x intersection z this side here. So you have x intersection x complement union x intersection z like this here. So now suppose this is a set that we have here, and this is our universal set here. Then this is the set x there. So the complement of set x is what is outside here. Then x is what we have inside there. So now if we say x here intersection its complement, we're going to have an empty set because there's no element that is found both in x and outside x. So meaning that here we're simply going to have this here will give us an empty set here. So we're going to have an empty set union x intersection z like this here. So then an empty set union with the set that we have this side, we're simply going to have x intersection z as the answer there. Okay, let's look at the second one. Then for the second one b here we have x union x intersection y like this here. So now we apply the distributive properties here. We're simply going to have x union x intersection x union y here. So now here x union x was simply just going to have the set itself x here. So we're going to have x here intersection x union y like this here. So the common element between x here and x union y is simply going to be the set x that we have here. Okay, let's look at the third one now. Let me just erase what we have here. Okay, so for the third one there, we have C, we have A union B minus C like this. So what we have inside the brackets here is simply set difference here. So this here is the same as A intersection B, or A union rather. So this is union here. So A union B intersection C complement like this. So then here we just distribute the sets that we have here. We're simply going to have A union B here intersection A union C complement like this here. Okay, so for the fourth one here, we have, let me just do this. Okay, so for the fourth one there, which is D there, we have P complement intersection Q union P like this here. So here, we're going to apply the distributive properties here. So we distribute P complement across the brackets this set here. So we're going to have P complement intersection U union P complement intersection P like this here. So now we know that P complement intersection P will simply give us an empty set this set. So I'm simply going to have P complement intersection Q union an empty set here. So therefore here we're simply going to have P complement intersection Q like this here. Okay.